Brilliant. So then let's get started. So the first session, as Gianni was just saying, is all about what are graph technologies and why would I use them in the first place. We're trying to make this more of a conversational format. So Emma and Gianni and I will be more discussing so that we are not putting you at risk of death by PowerPoint. We do have a few PowerPoint slides, though, in order to make things a little clearer. And maybe one thing up front, just to get started, we will be talking about what graphs are in the first place. We'll touch on a couple of use cases, and then we are really, really brave. We're doing something which we haven't done a whole lot in the past, which is we will try to explain to you the different concepts of graphs which we support with the Oracle database, because there are two fundamentally different implementations which we have. One is called property graphs. The other one is the RDF knowledge graph technology, which we've had for a long, long time in the database. And we'll try to make clear what the differences are, what to use in which case and why. And you tell us afterwards whether we've succeeded in either confusing you even more or whether it was helpful. So that's probably going to be the main part of today's talk. Then we'll briefly touch on graphs and machine learning before Melly takes us into that topic in depth in about 2 hours' time. Right, and then we'll give you a couple of hints as to where to find additional information or what to do next, maybe if you want to get started with this. So one thing up front, just to clarify, because not everybody is entirely clear about what graph technologies are and what graph analytics is useful for. When I say graphs, I'm not referring to pie charts or bar charts and interpreting those, but I'm talking about things like this. Graphs where we are representing entities as vertices, as we say, in a graph and connections between them. This is part of a small part and an outdated part of my Twitter network, and I still like using it to make clear what graph analytics can do for you, because at first glance, what you can see is this graph highlights the important vertices, so people who are either well-connected or connected to important people. It can also be used to identify communities in graphs, so those parts of the graph which is more closely interconnected than the rest. And you can find outliers, like Eva down here. Right? When I was looking at this for the first time, I thought, oh, what's poor Eva doing now? Why is she not connected to anybody? And the explanation is actually she's a friend of my wife's. So I have no business relationship with her, as I would with pretty much all of my other contacts, and so she is sticking out as the anomaly in my graph. So this is the kind of graph we want to talk about. And just to get started, maybe to warm up, first question, which I would briefly like to talk about with the others, is where did you come across graphs for the first time? So maybe Emma, do you want to start with a few comments on that?
Yeah, definitely. Thanks, Hans. So I think a lot of people don't realize, maybe I have to say, I admit, I think I did when I first started using these, but some people don't realize that they're using graphs every single day. So every time you do a Google search, for example, you are hitting the Google Knowledge Graph, which is a graph of linked data, linked entities. And on the right-hand side of your search results, you can go and try this out now, you'll see the results that come up in the right-hand side are all coming from the knowledge base, from the knowledge graph, and they will show information that's linked to that search term. So if we were searching for the term Oracle, we would see lists of acquisitions, we would see locations, we would see maybe senior members of the board, and those kind of things, all linked data there. So another two aspects, so I think Hans just showed it nicely, the LinkedIn social graph, but they're also using not only from from a personal perspective to view your network, but they as LinkedIn company are using this linked graph to enhance their search and job recommendations. So the entities in their graph database that are using are not only just people, but they're also jobs and companies and locations. And eventually it's really down to advertising and monetization and segmentation that they're using that graph for. Another one, social network. Obviously, I can't talk about social graphs and not mention Facebook. So these are the most successful social graph company with a very profitable advertising platform. Again, using segmentation for monetization.
Yeah, interesting stuff. How about you, Gianni? I mean, where did you come across graphs in your career previously?
Yeah, so the first real graph, knowing that it was a graph, was actually when the Panama Papers things were all around the newspapers and all, on every single website. And then with our colleagues, Robin Moffat, he started doing analysis about, oh, let's see if we can really find the same information. So by connecting the pieces together, thanks to the graph, you really find out that there is this company in Panama that has a bunch of relationship with people. Then going through the graph, you find nice names and interesting public figures, let's call it like that. But even before that, it was, so my background is really about analytics. And when it's about analytics, it's all about understanding what is a business like, what is the job of the person I'm speaking with. And most of the time when they start explaining me how they do their business, they just take a piece of paper and they start drawing a workflow, some boxes, some arrows and things like that. And that one is already a graph. So just speaking with any kind of business, the easiest way they have to explain you what they do is just by doing a graph. They never call it graph. They don't know that it's a graph, but that's really how I started having boxes and arrows all around me years ago already, before to know that it was actually a graph.
Yeah, that's interesting. Yes, I mean, most of the folks maybe online also know that I come from a geospatial background. Right, I came across graphs in a very different context to that as well. And in fact, everybody, all of you, are probably using that on a regular basis as well, which is in the context of road networks. Right, if you look at the road network, that's also a graph, and you would use graph analytics in a very specific type of use case on these road networks in your personal navigation device, or on Google if you try to find the shortest path from A to B, right? Because what happens behind the scenes is every road segment is stored as a connection, and every intersection is a vertex. And you don't really need the geometry. All you need is the abstract graph to do the actual calculation of finding the shortest path, the cheapest path, the fastest path, whatever you need, from A to B. And so that is also a graph implementation, of a fairly popular one, which is not obvious to everybody. Like in Gianni's case, the workflows. Great. So Gianni, as you were talking about the workflows and so on, what is it that you particularly like about graphs, and why did you stick with this topic in particular?
As I said, I really come from analytics. So my main business was all about finding information somewhere in a company, in the databases, and then make them useful for the company. And thanks to the graphs, you can really expand at this kind of information that you can use to better drive your company. They really give you a different point of view on the same set of information. So it complements your relational databases by giving you really different hints about what's going on and what you can do to even improve your business and keep going and just be successful in your company. So it's really this extending analytics thanks to a different point of view. That's really what I like about graphs.
Mm-hmm. Yeah, you also mentioned the easy modeling. This is one of the things which I personally find fascinating about graphs. Right, all you need is a blank sheet of paper. And contrary to relational databases, where you do all your ER modeling up front, and where you spend a lot of time setting up your environment, graphs, you can just get started. You extend things as you go along. You don't have a fixed schema. I think that is one thing which is interesting, but that's more on the property graph side. I mean, with your focus on RDF knowledge graphs, what is it that you like about these types of graphs?
Yeah, so there's a lot of similarities between the two graphs, but where I find knowledge graphs are really interesting and exciting is, firstly, and easy to use, is that they use a natural language representation inside the graph. So it's very easy to understand. The words are you can understand them and read them very easily, and they also, just opposite to property graphs, is that they do actually implement standards. These are W3C backed standards, which provides very rich vocabularies and modeling languages to help you to implement and interact with other graphs, and also have access to your data as well. This gives rise to the graphs being able, these knowledge graphs can be linked together. So you can link your knowledge graph internally across your enterprise. So if you've got different graphs, you're able to share data and query across these graphs using this interlinking. But you're also able to enrich and link to external graphs like DBpedia and Wikipedia, Wikidata. They expose knowledge graphs, and that is extremely powerful to be able to pull in all this extra data and knowledge and link it into your situation. The other final thing that I really like about knowledge graphs in particular is they also provide a way to do something called inferencing. So that's the ability to create new facts based on the existing facts. And we'll look at some examples about that later, I think. So.
Yeah, maybe it's a good point. Maybe it's a good time to move on to use cases. And as you were just talking about, these knowledge graphs which are externally available, maybe you can talk about one of your favorite use cases in that context.
Yeah, so this is a really powerful example of why the linked open data is so great. You can all go and have a look at this portal yourself. This is I wish they would do this in the UK. It's really interesting to have a look at all the different statistics they've got. But they've got about, I think it was like nearly 90 different data sets from different departments. I've got them here. So Ministry of Economics, Trade and Industry, National Agriculture, Food and Research. And they've been really able to combine all of this different graph data, this knowledge graph, to be able to query. And they've also incorporated geospatial data as well, so using this geosparkle vocabulary and query language to access the data. They've got about 2 billion pieces of information in the database, linked data in there, and it's running in the Oracle cloud with a hybrid backup to on-premise. So yeah, that's it, really nice.
Yeah, that's an excellent example. And one quick remark here from my side: we have designated this as an RDF slide with this little icon up on the top right, just so that you don't get confused when we talk about the different use cases or applications or technologies. If it only applies to one of the two concepts, property graphs versus RDF knowledge graphs, then we'll try to distinguish the content. You can always find on the top right corner what we're actually talking about at the moment. And if you're interested in this specific implementation, there is a full slide deck available on this, which was presented by Shuki Nishimura in spring at the Analytics and Data Summit, when we could still physically meet. Right, so that's the linked open data example. Thanks for that, Emma. Gianni, your favorite use case?
So a use case which I'm using often in the last few years. So a few years ago, Europe introduced the GDPR regulation, so the General Data Protection Regulation. It's a totally new rule that said companies don't own your personal data anymore, but they need to ask the people if they agree to being processed and all those things. And from there, many companies started worrying about, oh, I need to be able to track all my data. I need to find out which data I do collect about people, about customers, about employees, where they go, how I process them, and who is actually using them for what. And these lead directly to data lineage. And when you think of data lineage, it's all about the flow of data. Data starts somewhere, it keeps moving around, being transformed, being stored, it ends up being consumed somewhere else. That's obviously a graph. Like in this simple example, using the Oracle Graph Visualization tool, I'm just tracking which, let's say, where my database column called name is going. So I start from one single column on the right side of the screen, and I discover that going through an ETL, going through an analytical platform, my name column, which is a sensible information because it's a private information, end up being in a lot of objects, like on the left side. All those things are people consuming this information. So thanks to the graph, I can easily track where there is a problem. Oh, you are not allowed to do this anymore. So please remove name, first name, emails, all those things from all these kind of reports, for example. Other uses, there was Ludovico Caldara, was working for CERN a few months ago. They had a huge database. Actually, they had tons of databases. And they say, oh, we have so many, we are not tracking anymore. Who is accessing what and how? And thanks to a graph, they could easily, like we say, reorganize the full database, saying, okay, all those people connect to these schemas. So let's move all those schemas together. Let's move these other schemas together. So thanks to graph, you can reorganize your hardware, your resources, to simplify IT management just by redefining which database you have, who is accessing it, and for what needs. That's another use case that I often find in companies and customers.
Yeah, good stuff. Indeed. What we've seen a whole lot in customer situations at the moment is actually related to security, but in the wider sense, it's to do with fraud detection. So many of our current customers on the property graph side, note the property graph markup here, on the property graph side are using our graph technologies either for fraud detection in financial services, in money transfers in particular, or fraud detection in public safety, like in law enforcement and tax evasion and so forth, kind of related to the Panama Papers example, which Gianni was already referring to a little earlier. So these two screenshots were kindly provided by a company called PaySafe. PaySafe are one of the leading providers of e-wallets and online money transfers. And what they've shown here is how fraudsters are using their systems to work around limitations and to try to obfuscate money flows. So on the left-hand side, what you can see is every vertex, every dot you see here is an e-wallet. And if this yellow dot down here, if that is, for example, a betting site with a limit of $10 per bet, and there's someone who wants to spend $50 or $500 maybe on a bet, or what do? Well, they open 50 accounts, 50 wallets, and then transfer $10 each, and then use the $10 per wallet and spend them on that betting site. Now that obviously is undesired behavior, and so they try to identify these kinds of cases. That's more on the simple side, but very obvious. You can also see graphs can be very visual and help you identify these kinds of things very easily. As opposed to the right-hand side, where the scenario is, again, you have all these dots which are representing wallets, and all the lines which are representing money transfers. And there you can see you primarily have one source down here and one destination, and the money flows back and forth between all these different wallets, but pretty much all of it ends up in one and the same place, which clearly indicates that somebody is trying to hide money transfer in lots of data, essentially. So these are things which you can do very nicely with graph analytics. We have the session presented by Alberto from CaixaBank, more geared towards social network analysis, but I think he'll briefly touch on one of the other projects they do, which are also related to fraud analytics in his talk. So stay tuned for more details on that one. Good. So that covers pretty much the introductory part. Now, as I said, we're trying to be brave here today, and we're trying to give it a go and try to explain to you the difference between property graphs and RDF graphs. So maybe Gianni, if you want to start with property graphs, just to give folks a little feeling for what the main fundamental aspects are.
Yes, so we already said it's extremely simple to get started with a property graph, because all you need is a piece of paper and a pen. Why is that? Because a property graph is composed by only two kinds of objects. You have the rounds, they are often represented as rounds, called vertex or node, synonyms. And the other component is just lines, arrows. That's called an edge. You take a bunch of them, and that's your property graph. It's really as simple as that. Now, to make it more explicit, we can look at an example of a property graph. So a super simple property graph is the one that you have on the screen. First part of the graph are the edges, the nodes, sorry. So all the nodes, the rounds, what they are composed by. So they have a vertex ID. That's mainly a technical field. We need to identify them in a unique way. So we have a unique ID for every single vertex. Vertices, they can have a label. They generally have a label. A label really identify the vertex. For example, it tells you this node is a customer. This one is a product. This one is a country. And then because it's called property graph, we obviously have properties. And properties, once again, is extremely simple. It's just a list of key values. So you have a property is really one key equal one value. And the fun part, the interesting one, that the list of properties is totally free and dynamic. So inside the same graph, every node can have a different set of properties. It's not because one has 0 properties and the other one has 200 properties that your graph has 200 properties everywhere. Nope, it's totally disconnected. Every node is their own life. They are totally independent. That's really the easiness and the freedom that you get with the nodes. And the other component of the graph are the edges. So edges always connect two nodes together. Once again, we have an edge ID. This is really a technical field. You will really never use the edge ID. It's there because we need to identify them in a unique way. An edge as a label. The label is often an action, something that defines the link between the two nodes. Like the one at the bottom is created. So it's really that Josh created Ripple. So it really defines what kind of relationship there is. And then we have properties again. Same things as the edges, as the nodes, sorry. Properties are key values. And the list, once again, totally free. One edge, no properties. Next edge, 10 properties. The next one, 200 properties. It's totally free. The only limit is you and how big is your piece of paper, I will say. It's really just nodes, edges, and nothing else. Just start building your graph. As simple as that. Now, what can you do mainly with your graph? There are two kinds of action that you do with your graph. Generally, you can do querying. So you just ask your graph questions about, oh, what is the structure like? So how can I connect things? Or how, if I start from this node, where do I end up if I follow a given path? It's like if you follow your GPS when you go from point A to point B, it's the same thing. So you just navigate through your graph to find connection and relationship between things. And then obviously you can also extract the results being just nodes or edges independently or subgraph for a given topic, for example. The other main job you will do with your graph is the smartness, really the algorithms part. Graph algorithms is really a big thing in graphs. You can calculate a bunch of things. The most known one is probably PageRank. You all know Google. Google used PageRank at the beginning to be the best search engine ever, kind of. So PageRank is really a graph thing. There are graph theories if you did math at school that teach you all those things. You can also do detection of clusters, detection of communities. You take a big graph and then you just cut it down in communities based on the structure of the graph itself. You can find how do you go from point A to point B in the cheapest way, in the fastest way, in the shortest way. So there are really a lot of algorithms out of the box. With Oracle Property Graph, you have like 40 or 50 algorithms that do a lot of things. That's really what you can do with a property graph easily.
Okay, interesting. So that covers the property graphs, and maybe we can now move on to the knowledge graphs. Emma, maybe you can briefly explain what RDF knowledge graphs are all about.
Yeah, for sure. So, so a lot of the concepts are similar. with knowledge graph to what Gianni just introduced, but there really are some key differences. So you could think of a knowledge graph as sort of the intersection between a database, knowledge base, and a graph, this center area over here. But the key differences are, firstly, the entities are, the nodes are things, and they're not considered strings, they're things. And each one, this non-literal, is assigned a unique, global unique identifier, makes use of the URIs. The other key difference is the use of this formal structure and semantics. So in a knowledge graph I mentioned earlier, it uses natural language representation, which makes it easier to understand, but also easier to query. And in humanities, maybe if you go to the next slide, Hans, that would be great. So in humanities, the term semantics is used to define the meaning of a word, but when it's used in the context of the semantic web, as you can see here, the semantic web is all around how to formally define a meaning that can be used in computation. So I'll just step to the side. So it was Tim Berners-Lee in 1994 that first defined the standards HTML, HTTP. And they created the largest hypertext system in the world, the World Wide Web. Now, that made it possible for humans to understand the information that was being shown to them. So if I was to go to a website, I could see that the product I was looking at is the same product that I'm seeing on a different website. But how do you make a machine understand that when they're looking at product A on Amazon, the machine is looking at the same product that's being shown on eBay, for example? So the ultimate goal of the semantic web is to make a machine understand the internet data so it can interpret the meaning, know what to do with it and how to represent it. So the semantic web, which was first proposed by Tim in 1999, was a collection of standards. It's an extension of the World Wide Web that was the W3C, that's called the semantic web. So if we, could you go to the next slide, please? So these standards, these are here, you can go and visit the semantic web section of the W3C. They were proposed by Tim around using linked data. So how to weave information together so that computers and machines can understand the data sharing. And the most fundamental part of this was the standard data model, which is called RDF. So that's why these graphs, knowledge graphs, are sometimes referred to as knowledge graphs, RDF graphs, sorry. And RDF stands, this is a data format and exchange protocol, and it stands for Resource Description Framework. There were other standards that were proposed with the linked data, with the semantic web. These are vocabularies used to describe your data. So you can use these, such as OWL and SCOS. These are standard ontology languages and simple knowledge organization systems to describe your links, your edges between your data. And you can see here in the little picture, this little graph in the bottom right-hand corner, they're using SCOS to show this vocabulary to show this. And this is a standard. So when you're working with other data and other graphs, it's very easy to interlink these two together. So a graph database can exist, but for it to be a knowledge graph, for it to be a semantic web graph, it has to adhere to these standards. Just before we go on to the next slide, I wanted to point out there's also a query language, which is for pattern matching and for just general querying, but it's also an HTTP protocol. So you're able to just query your knowledge graphs very, very easily. And yeah, that was all for this slide, really. So I wanted to just go a little bit deeper into what are the actual sort of the most basic elements of the graph, and these are edges and vertices, similar in a similar way that we had with property graphs. But the difference is that they are the atomic unit of an RDF graph, a resource description framework graph, is that they are founded on a concept called triple. And a triple contains a subject, a predicate, and an object. And in an RDF graph, in a semantic web graph, they are all URIs. So the edge labels are URIs. So over here, the subject is a URI. The edge is also a URI, and the destination vertex or node is a URI or a scalar. So for non-literals like numbers, they can be not URIs. And that's why the graph is also called sometimes a triple store. You're also, so I mentioned earlier about one of the things that I like about property graphs is the interlinking your data. And because we're using this concept of URIs, you can have your graph integrate with and interlink with public graphs. So you can see here the Wikidata or DBpedia, for example, they've got 170 million facts that are publicly available, which is really powerful for when you're setting up your system, your ontologies, those kind of things. And the final thing I wanted to cover about knowledge graphs, which I said I would do earlier, was inferencing. Now, using these standards, you're able to set up rules in your configurations and create inferencing that can run inside the database. Okay, so you don't have to export the data anywhere to create new facts. And this is really powerful. So this example here, we've got this piece of information, this linked data. San Francisco is in California and California is in USA. So you can create a new fact using inferencing that San Francisco is in USA. And you might say, oh yeah, that's obvious, but being able to create this information is very powerful, because if you think about when you've got really large data sets, being able to run through and automatically generate this is very powerful.
Yeah, no, absolutely, totally agree. Thanks for the explanation, Emma. I think that was very helpful to get more of a complete picture of what RDF knowledge graphs are about. The interesting thing from my perspective is also that the adoption varies a lot from one domain to the other, and also regionally. I mean, what I've observed is that in, for example, the life sciences, in healthcare, in media, sometimes in manufacturing, but there it depends where, we would see a lot of people using this, at least in some countries, while in others these concepts are still not so common. So let me try to, yes, go ahead. You wanted to say something?
Oh no, I was just going to say I also see a lot of people sharing their ontologies and their rules, their schemas as such, which is quite good.
Which takes away a lot of the burden of coming up with your own schemes, with your own vocabularies, with your own ontologies and so forth. True, and I think that's also one of the things which helps drive the adoption in the healthcare space, because there are large ontologies in the life sciences describing, for example, proteins or the like, and that makes it much easier to search also in these kinds of things. So if I try to briefly summarize what we've been talking about. So Gianni was talking about the property graph side of things, and I hope it's become clear that property graphs, the beauty of property graphs is that they are so simple in that you can model any entity as a vertex in a graph. You can model any relationship as an edge in a graph. There is no formal restriction. There are no semantics associated with either the vertices or the edges, at the cost of not having inferencing, of course. Also, property graphs are younger in the sense that they've only become popular a couple of years ago, as opposed to the semantic web, which has been around since 1999 when Tim Berners-Lee first coined the term, which means that at the moment, at least not for the time being, we don't have any standards. Neither do we have standard vocabularies, nor do we have standard query language and so on. That is an ongoing effort. So if anybody is interested in standardization in this context, we are actually actively involved in the standardization of a property graph query language, but doesn't exist yet. much of the work is still community driven. And I hope it's become clear from what Gianni was saying that the emphasis for property graphs is on analytics, basically making use of the fact that you're explicitly storing and handling the relationship, contrary to a relational database where, you know, whenever you join things or whenever you have a relationship, you join two tables. Here, we actually physically store the relationship, which is powerful in that you can use it for fast traversal, right? And then that gives you the possibility to do all kinds of graph analytics for the purpose of anomaly detection, or you'll hear about more targeted marketing from Alberto in the next presentation. We can do dependency analysis, like what Gianni was explaining in the context of data lineage, or the case in CERN with the security. All of these things can be managed very nicely as property graphs, where you don't have the formal theoretical foundation which you have with RDF graphs. RDF graphs are great in that they associate meaning with every entity. So if there is like in the JSTAT example, if there is an unemployment figure, it is unemployment as per the definition of JSTAT in this very context. And you can always go back to the actual definition of what unemployment means in that context. And it also allows you to do inferencing. You have all the description logic going along with it. You have fixed vocabularies, curated terms, ontologies, all the standards that go along with the RDF knowledge graph, which make it a bit of a steeper learning curve from my perspective, but which make it a very powerful thing to use for, as I said, associating data with meaning. One interesting aspect in it, and Emma just touched on it in the context of associating your own entities with content which is up on the web, is the possibility of using federated queries across your own data and open data, which or other data sources which are sitting somewhere else. So these federated queries are great, and customers, for that very reason, use it for data integration across different databases. They use it for semantic search. Like if you are in healthcare and you are looking for all documents which are related to upper extremity fractures, then you also want to find all those documents which are talking about hand fractures, arm fractures, and so forth. And the inferencing part in the RDF knowledge graph concept helps you to generate these kinds of facts on the basis of what you have. Right, one quick remark here. We can interoperate between the two models in the Oracle database, but in the interest of time, let me just move on, because we still wanted to briefly touch on what this is to do with machine learning, because we are part of the analytics and data community here, and machine learning was the topic of the day yesterday. We wanted to briefly touch on that. Gianni, maybe you can say a few words about the relationship between graph analytics and machine learning. Is that competitive? Is that complementary? What would be your take on that?
So for me, it's extremely complementary. So you generally do machine learning mainly in your database, taking your tables, you use all the columns as features, and then you train your model based on a table or a view. But if you now add in the graph aspect, so if you load your data into a graph, and from the graph, as I said earlier, you can do a query on the graph. You can export information about the graph. You can, for example, run algorithms. You do a calculation in the graph. You export the result of the calculation. You are generating new information and new features, which will make your model extremely more powerful, because it's a common known thing that the more features you have, the better your model will be trained most of the time. So if on your, I would say, basic data, you add a touch of the graph aspect, the structure, the relationship between objects, you're really adding something extremely powerful, and your machine learning model will clearly get a lot of benefits learning by it. And then obviously you can go in the other direction. So once you have machine learning models, you can classify your information, so you can generate new information, creating communities, creating clusters, creating classes. And then if you bring this one back into your graph, this can be properties, can be labels, can be those kind of information, which can help you in having a faster or a better query on your graph. So it's really a two-way directional thing. You can use your graph to make your machine learning better, or you can use your machine learning models and train models to make your graph analysis more interesting, fully interconnected.
Good stuff. I think in the interest of time, I'll skip over the example which I briefly wanted to explain at this point because we don't have time to go into it. But just one quick remark at this point. Graph analytics can be extremely powerful in that it takes into account the relationships, which plain machine learning, if you just look at the attributes, for example, of entities, doesn't know about. So, being able to associate students with courses and then looking at this student being part of that course, being on the same course with that student who's on the same course as this student and so forth, is something which is not easily accessible to convolutional neural networks, which is why the accuracy of graph algorithms without any training is higher for these connected use cases. But I think in the interest of time, we'll skip over that and postpone the discussion to Melly's talk later today. So maybe a few remarks on knowledge graphs or RDF knowledge graphs and machine learning from your side still, Emma?
Yeah, just so very quickly. So there's no inbuilt machine learning as such, like with what Gianni was talking about, but you do have the ability, especially using within the Oracle database, is to export your knowledge graph directly into PGX and run all of those algorithms that you saw there. You can use the Oracle ML straight directly onto the data, and you can also just access the data directly. So just using standard, whatever your favorite language is, Python or whatever, to run the machine learning algorithms and APIs that you like already. So you don't have to use something that's inbuilt. You can just access the data directly. What I wanted to just point out, there's the last 2 points quite nice when you are combining RDF and machine learning, is that the inferencing that I was talking about earlier, this creation of new data, this could be used for your training data sets. So it gives an extra angle, being able to create extra content. And you can also import existing ontologies to start, if you're, for example, if you're creating automatic ontologies, those kind of things for machine learning. So yeah, that was it.
Good point. Great. Perfect. So we are 4 minutes over time. Let me just quickly touch on how Oracle fits into that as a summary. I'm not sure if everybody is aware, but the graph features, be it the RDF property graph, the RDF knowledge graph, or the property graph features, are included with every edition of the database without additional license cost. And I hope it's become clear that they are complementary to the plain relational technologies. You can use them very nicely in the context of analysis, particularly when relationships play a role. Plus, you can use them to complement machine learning, as Emma was also just saying, making use of existing knowledge which is sitting in the ontology, for example. That's where it becomes very powerful. The property graph technologies are mostly around algorithms and pattern matching. For that purpose, we do have an in-memory analytics engine, which is very scalable, which Alberto will talk about in 10 minutes. And we have visualization and notebooks going on with it and so on. The RDF knowledge graphs have been around for a long time. As I said, we've actually implemented them in Oracle 10G release 2. They use Oracle as a triple store, that has all the appropriate security also going on with it, which is interesting for our national security customers who are using this technology big time. And we have support for all the standards like Sparkle. We can do Sparkle in SQL and so forth. And we have made this technology available, of course, on the database cloud services, because it's, at the end of the day, it's just the Oracle database. We have announced the availability of a dedicated managed graph cloud service, and we hope that we'll be launching that later this year. Right, so that wraps it up. I have still a few more links here. If you found this session useful and you want to learn more, there is an oracle.com vanity URL. If you say oracle.com/go-to/graph, that will get you to the graph page. There's a blog. There is a nice blog also by the A-team, so Emma's team. Michael Sullivan has created a very nice overview blog post on where to find information on RDF knowledge graphs in general to get started. And we have regular Ask Tom sessions. I think I'll leave it at that in order to give you 8 minutes for either questions or to hop on the Slack workspace if you have sort of further questions, if you want to interact with either of us, Gianni, Emma, or myself. We will still be around. I mean, Gianni, Emma, and myself will be moderating the rest of the day as well. But if you have any questions, feel free to post them in the Slack workspace or use the Q&A box now. I'm just checking any questions at this point.
We already took care of the question while each other was speaking, so.
Yeah.
Perfect. See, this is one of the things when I'm usually so concentrated on my presentation that I don't pay attention to the Q&As. Thanks a lot for that, Gianni. So with that, let me quickly go back to the slide for the break so that we can get ready for Alberto's session. On the hour, we will be starting the next presentation, which is by Kasia Bank.
Hans.
Emma, I was just about to say, you sound like you were taking a deep breath and you wanted to say something.
A question came through. So do you have any references where customers implement graphs with machine learning?
So one nice use case, and I'm sure Millie will touch on that as well in her presentation in an hour's time, is what our friends at PaySafe are doing in the context of fraud detection, because they are not only using graph analytics for the purpose of finding specific patterns in the data sets in order to identify fraudulent transactions, but they also are exploring how to use that knowledge which they've gained from the different patterns to feed it into machine learning platforms such that they would identify these kinds of patterns and related patterns more easily. So this is one thing which currently happens, and then in the RDF knowledge graph space, in terms of public references, I'd have to have a look. But it is an interesting topic because you can, get around the cold start problem with all the knowledge you already have in a knowledge graph by, putting that in first before you actually run the inferencing. But that was a good question. Good. So let me quickly go back to the appropriate slide. Here we are. And then we give you a few minutes of break to get a cup of coffee or so here we are.